Hello everyone, I am Johnard G. Fiel. You might be wondering why it doesn't sound like my voice. That is because I am using an AI voice generator. I will be your science teacher for school year 2022 to 2023. Please note, I do not own nor claim any ideas or information in this presentation. All credits shall be given to the rightful owners and references. This presentation is for educational purposes only. Any policies that might be violated by the creator of this presentation in the near future does not directly affiliate to any organization outside this platform, such as Philsaga High School Foundation, Incorporated. All actions made in here are personal and voluntary. You may use this presentation as a reference for your Quarter 1 Module 1. Always remember the given general instructions. You are expected to complete the activities of your self-learning material within 2 weeks. Please do not leave out any activity incomplete. Should you need clarifications, please feel free to contact your teacher using the contact details in your envelope. Thank you and keep safe always. You have learned in your previous years the layers of Earth. This set of pictures shows the Earth's core, mantle, and crust. The outermost layer of the Earth is the crust. The crust and uppermost mantle make up the Earth's lithosphere. Due to Earth's heat beneath, the surface of Earth constantly moves. This continuously moving part of the Earth's crust is what we call plates. When this happens, an earthquake may occur. There are two types of earthquakes, but I will be discussing briefly one of it, which is tectonic earthquake. This type happens when the shifting of Earth's plates is driven by the sudden release of energy within some limited region of the rocks of Earth. An earthquake has also an anatomy, the focus, or hypocenter, depth, distance from force, distance from epicenter, and the epicenter. It shows that surface directly above the focus is the epicenter. To determine that you really are ready for our next lesson, let's have an activity. Are you ready? Okay, let me read first all the questions. Question number 1. What is the outermost layer of the Earth? A. Crust. B. Inner core. C. Mantle. D. Outer core. Number 2. The crust and upper mantle make up Earth's A. Asthenosphere. B. Continents. C. Core. D. Lithosphere. 3. What do we call the continuously moving part of the Earth's crust? A. Fault. B. Fissure. C. Fracture. D. Plate. Number 4. This earthquake type happens when the shifting of Earth's plates is driven by the sudden release of energy within some limited region of the rocks of Earth. A. Aftershock. B. Foreshock. C. Tectonic. D. Volcanic. Number 5. It is the location on the Earth's surface directly above the focus of an earthquake. A. Center. B. Direct center. C. Epicenter. D. Epicenter. You may pause the presentation if you are not yet done answering. You may also comment your answer in the comments section below. I will be giving extra points in your written test for participation. Just comment your name, section, name of activity, number or item, and the correct answer. Sample comment is shown on the screen below. Thanks for trying your best to remember what you have learned in your previous year's lesson and answering the short activity. Now let's all read the objectives for this module. 1. Describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory. 2. Enumerate ways to ensure disaster preparedness during earthquakes, tsunamis, and volcanic eruptions. 3. Suggest ways by which one can contribute to government efforts in reducing damage due to earthquakes, tsunamis, and volcanic eruptions. 4. Design a hazard map composing different natural hazard. Now that you know what to expect, let us move to our lesson proper to firm up our knowledge. We will be discussing 4 sections of topics here. A brief review and discussion of layers of Earth, brief introduction of plate tectonics, mountain ranges, volcanoes and earthquakes, as well as how to use hazard map. Let's get started. Layers of Earth. Our Earth has 4 layers consisting of different materials, namely, crust, mantle, inner, and outer core. For this module, we will focus on the lithosphere, which is composed of the crust and the upper mantle. The crust is everything we can see and study directly. The thinnest layer of the Earth, the crust still measures about 40 kilometers on average, ranging from 70 kilometers in depth. But at the scale of the planet, that's less than the skin of an apple. There are 2 types of crust, continental and oceanic crust. Oceanic crust is denser and thinner and mainly composed of basalt. Continental crust is less dense, thicker, and mainly composed of granite. Earth's crust is not all in one piece and lithosphere is said to be in constant but very slow in motion. These motions are not the same everywhere. This movement of the lithosphere is called tectonics. Now moving on to the plate tectonics. Plate tectonics. According to the plate tectonics theory, the entire lithosphere of the Earth is broken into numerous segments called plates. In this background, the arrows show the direction of the plate movement and the other lines are the fault lines. Plate tectonics theory explains how major landforms are created as a result of Earth's surface movements. In plate tectonics, Earth's outermost layer, or lithosphere, made up of the crust and upper mantle, is broken into large rocky plates. These plates lie on top of a partially molten layer of rock called the asthenosphere. Due to the convection of the asthenosphere and lithosphere, the plates move relative to each other at different rates, from 2 to 15 centimeters per year. This interaction of tectonic plates is responsible for many different geological formations such as the Himalaya mountain range in Asia, the East African Rift, and the San Andreas Fault in California. This interaction of tectonic plates is responsible for many different geological formations such as the Himalaya mountain range in Asia, the East African Rift, and the San Andreas Fault in California, United States. This means that according to plate tectonics, the lithosphere is broken into huge plates that slide under, over, and past each other, resulting to mountain building, volcanism, earthquake, and other phenomena. Now let's moving on to the mountain ranges, volcanoes, and earthquakes. The mountain ranges, volcanoes, and earthquakes. Let's first discuss about volcanoes. Volcano is a mountain or hill, typically conical, having a crater or vent through which lava, rock fragments, hot vapor and gas is being or have been erupted from the Earth's crust. Volcanoes are categorized into 3 main categories: active, dormant, and extinct. An active volcano is one which has recently erupted and there is a possibility that it may erupt soon. A dormant volcano is one that has not erupted in a long time, but there is a possibility it can erupt in the future. An extinct volcano is one which has erupted thousands of years ago and there's no possibility of an eruption. Volcanoes are grouped into 4 types: cinder cones, composite volcanoes, shield volcanoes, and lava volcanoes. There are also types of volcanic eruptions. It depend on various factors such as chemistry of magma, temperature, viscosity, volume, presence of groundwater, and water and gas content. Following are the different types of volcanic eruptions: hydrothermal eruption, phreatic eruption, phreatomagmatic eruption, Strombolian and Hawaiian eruption, Vulcanian eruption, subplinian and Finian eruptions. Read more details about types of volcanoes and volcanic eruption on page 5 to 6 in your module. Let's move on about earthquake. An earthquake is a weak to violent shaking of the ground produced by the sudden movement of rock materials below the Earth's surface or a vibration of Earth due to the rapid release of energy. The earthquakes originate in tectonic plate boundary. The focus is point inside the Earth where the earthquake started, sometimes called the hypocenter, and the point on the surface of the Earth directly above the focus is called the epicenter. There are two ways by which we can measure the strength of an earthquake: magnitude and intensity. Magnitude is proportional to the energy released by an earthquake at the focus. It is calculated from earthquakes recorded by an instrument called seismograph. It is represented by Arabic numbers such as 4.8, 9.0. Intensity, on the other hand, is the strength of an earthquake as perceived and felt by people in a certain locality. It is a numerical rating based on the relative effects to people, objects, environment, and structures in the surrounding. The intensity is generally higher near the epicenter. It is represented by Roman numerals. In the Philippines, the intensity of an earthquake is determined using the Phillips earthquake intensity scale. There are two types of earthquakes: tectonic and volcanic earthquakes. Tectonic earthquakes are produced by sudden movement along faults and plate boundaries. Earthquakes induced by rising lava or magma beneath active volcanoes is called volcanic earthquakes. At present, Phillips operates 108 seismic monitoring stations all over the Philippines. These stations are equipped with seismometers that detect and record earthquakes. Data is sent to the Phillips Data Receiving Center to determine earthquake parameters such as magnitude, depth of focus, and epicenter. Together with reported felt intensities in the area, earthquake information is released once these data are determined. Last and definitely not the least is the mountain ranges. Mountain range is a landmass that projects well above its surroundings, higher than a hill. For some people, a mountain may refer to a place that has an elevation that is significantly higher than its surrounding area. Geologically speaking, the word refers to a large and elevated landform that is formed through tectonic forces. It is usually have steep, sloping sides and sharp or slightly rounded ridges and peaks. Primary features of a mountain include top or summit. Orogeny refers to the forces and events that lead to a large structural deformation of Earth's lithosphere. Came from the Greek word oros for mountain and genesis for creation. Product or movements of tectonic plates. During orogenesis, orogens, or deformed rocks formed as the continental plate is crumpled and push upward. The end product of this geological process is a landmass we simply call as mountain. Mountains do have also characteristics. Mountains are prominent landforms that have significant heights above sea level and or the surrounding land. They are steeper than hills. A mountain or mountain range usually has a peak, which is a pointed top. Mountains have different climates than land. Climate is the weather over an extended time period for a specific area. The climate of mountains tends to include colder weather, wetter weather, and thinner air. Thin air refers to the fact that at the higher altitudes of a mountain there is less oxygen to breathe. Also, mountains generally have less hospitable conditions for plants and animals. This leads to quite different evolutionary adaptations for those plants and animals that make higher elevations their home. Most mountain ranges are typically located either in the Pacific Ring of Fire or the Alpine Belt. The Pacific Ring of Fire or the Circum-Pacific Seismic Belt is a horseshoe-shaped region in the Pacific Ocean basin that is characterized by a large number of earthquakes and volcanic eruptions. Meanwhile, the Alpine Belt is a mountain range that is created by ongoing collision of plate tectonics between the northward moving African, Arabian, Indian plates and the Eurasian plate. Now that you know about volcanoes, earthquakes and mountain ranges, let us now try to describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory by doing the next activity. Look and observe carefully. What can you observe on the map 1? It is stated that the dark areas are the earthquake epicenters. Write your observations on the space provided on page 8 of your module. Look and observe carefully again. What can you observe on the map 2? It is stated that the dots are active volcanoes. Try to compare map 2 and map 1. Write your observations on the space provided on page 8 of your module. Lastly, look and observe carefully. What can you observe on the map 3? It is stated that the coarse and darker areas are the mountain ranges. Try to compare map 1, map 2, and map 3. Write your observations on the space provided on page 9 of your module. What did you observe in the previous activity? Did you find the earthquake epicenters, volcanoes, and mountain ranges close to each other if not situated in the same locations? Have you ever wondered how this could be possible? Remember that plates are in constant motion. As they interact along their margins, important geologic processes take places, such as the formation of major mountain ranges, active volcanoes, and earthquake epicenters. It means to say that, where there are earthquakes, crusts can either meet or move apart and form mountains and volcanoes. Plate movements may result in earthquakes. Earthquakes may happen anytime, either on land or underwater. Earthquakes on land can be caused either by tectonic plates movement or volcanic eruptions. Earthquakes under the sea can cause a tsunami. Our country, the Philippines, is situated in a place where plate tectonics is very evident, the Ring of Fire. It is a long chain of volcanoes and other tectonically active structures that surround the Pacific Ocean. The Ring of Fire is one of the most geologically active areas on Earth and a site for frequent earthquakes and powerful volcanic eruptions. Study Figure 6 on page 10 of your module. It shows the active volcanoes all over the Pacific region. Go back to Figure 2 on page 4 to see again the moving plates. You will realize that the volcanoes in Figure 2 are also situated in the areas of plate movement. You have seen the maps of the Pacific Ring of Fire. This time let's see how our country, Philippines, is at risk of disasters related to geologic activities. As we are known to be resilient, we have high hopes that our resilience could also mean preparedness at all times. See Philippine map on page 11 of your module. It clearly shows the numbers corresponding all the names of provinces in the Philippines. Before we move on to our next activity, let us first discuss what is hazard map. Hazard maps are developed to illuminate areas that are affected or vulnerable to a particular hazard. They are typically made for natural hazards such as earthquake, ground motion, flooding, landslides, liquefaction, and tsunami. Hazard maps are tools that, when properly utilized by planners, developers, and engineers, can save lives and economic losses by avoiding exposure to some hazards while designing other development to mitigate or neutralize the potential negative effects of these hazards. I'll show you an example of hazard map. This picture is the Philippine map. Hazard map must include legend or symbols to describe the risk of certain province in the Philippines towards earthquakes, landslides, volcanic eruption, and risk to tsunamis. Lines represent the boundary between provinces. The pure shaded black represent high risk area. Slant shaded black and white represent medium risk area. Horizontal shaded black and white represent low risk area. And lastly, pure shaded white represent no risk area. Now that you know the basic parts of hazard map and already have a reference for the complete provinces of Philippines, I will now check your understanding through answering the next activity. Hazard map reading. Study the hazard map below, which is risk to earthquakes. You may also see it on page 12. Use Figure 7 map or political map of the Philippines on page 11 and this map to identify the risk to earthquake of the given provinces. Agusan del Sur, Agusan del Norte, Bohol, Palawan. You may write your answers in the comments section by following the instructions I said earlier. You may also write your answer in your modules. Study the hazard map below, which is risk to earthquakes-induced shallow landslides. You may also see it on page 13. Use Figure 7 map or political map of the Philippines on page 11 and this map to identify the risk to earthquakes-induced shallow landslides of the given provinces. Agusan del Sur, Agusan del Norte, Cebu, Palawan. Study the hazard map below, which is risk to volcanic eruptions. You may also see it on page 14. Use Figure 7 map or political map of the Philippines on page 11 and this map to identify the risk to volcanic eruptions of the given provinces. Albay, Davao del Norte, Leyte, Palawan. Study the hazard map below, which is risk to tsunamis. You may also see it on page 14. Use Figure 7 map or political map of the Philippines on page 11 and this map to identify the risk to tsunamis of the given provinces. Cebu, Agusan del Sur, Bohol, Western Samar. Now that you know the risk to a specific natural hazard of some provinces of the Philippines, do you know what to do before, during, and after a natural disaster? Here are some tips from www.ocd.gov.ph. This is what you should do before, during, and after an earthquake. This is what you should do before, during, and after a landslide. This is what you should do before, during, and after a volcanic eruption. This is what you should do before, during, and after a tsunami. This time, you will be going to answer the activities provided in your module. This will serve as an assessment if you really learn from this module. In your module in the Deepen part, page 20. Activity 2 is multiple choice. All you have to do is read the statements questions carefully and write your answers in the space provided. Sample of how to answer is shown. In your module in the Deepen part, page 21. Activity 3 is critique writing. All you have to do is read the following written composition below. Critique each statement by following the numbers as your guide. If the bold word for that sentence is correct, write check symbol, and if wrong, put X symbol on the space provided each item. I'll give additional 5 points each per item to those who can rewrite the wrong term into correct term. Sample of how to answer is shown. In your module in the Deepen part, page 22. Activity 3 is fill in the box. All you have to do is complete the table below by choosing the given terms in the choice box. Write only the letter of your answer on the table below after the number. You can also read the charts from page 16 to 19. There are items that have more than one answer. Sample of how to answer is shown. For you mini task, see it on page 23. All you have to do is design a hazard map on region 13, or also known as Caraga region, composing different natural hazard. Use the map beside for your reference. This serve as your mini task. You may do your output on the space provided in your module, or if space is not enough, you may use another sheet and attach it on the module. You will be rated based on the following standard: accuracy, content, and relevance. Sample hazard map is shown. Thank you for listening and watching. I hope you learned a lot from the discussion. Leave comments and suggestions in your modules or in the comments section below. Feel free to contact me during office hours if you have inquiries. God bless and stay safe.